So hi everyone, excited to be here, first time in Atlanta for me. And I'll be talking from continuous profiling to continuous optimization. So just a word about myself. My name is Noam Salinger. I'm a product manager at Granulate. Like many other Israelis, I started off my career in software development and transitioned to product management in the past couple of years. And currently I'm working at Granulate. Granulate is an optimization company. I'll elaborate a little bit more about the company itself following up. So what are we going to be talking about today? So we're going to start off talking about the current state of the optimization. From there, we're going to transition and talk about the concept of continuous profiling, what it is, how it works. From there, transition into what's continuous optimization. And I'll leave some place at the end for questions. So if you guys want to ask anything, feel free to question at the end. OK. So starting from the top, so why optimize at all? So it's quite straightforward, basically. There are two main components into why turn to optimization. First one would be to improve application performance. So we all need to adhere to those strict SLAs. We're living in dynamic environments that are changing all the time, and we want to reach those top-performing applications. And the next thing is the fact that we want to improve the user performance and keep it as optimal as possible as we can. The second component would be the fact that infrastructure costs keep on raising. The more we improve, the more customers we have, it goes up and up. And the last thing is the fact that it's part of every software company's unit economics. So basically, improving it means that we have a better business running. So let's start off with a few traditional approaches into optimization. Basically, these are why people, like the go-to solutions when people want to optimize their applications. So one would be cloud hygiene. So basically, starting from visibility, breaking down those silos, and understanding exactly what's costing more in your environment. Next, people turn to right-sizing. So basically, finding the right VM for your application, making sure that you're not over-provisioned. Next would be going to schedule operations, so basically shutting off resources that are not used and eliminating any of those manual mistakes that happen all the time in your environments. Last would be discount purchasing, so people turn to discount purchasing, whether it be RIs, preemptables, or using spot instances in order to improve the costs. So these are all the traditional approaches, but there are a few problems with them. So basically, it's diminishing returns. So the more you use them, you're going to see less and less impact along the way. In addition to that, what makes it even harder to optimize your environment is the fact that it requires a lot of engineering effort in order to achieve those optimizations. And the more and more you optimize, you're going to see less and less results. And that's why we need new approaches into optimization. So I'm going to start off talking about the concept of profiling, and more specifically around what's continuous profiling, which is a new approach that's recently been getting a lot of attention. And let's start from there. So basically, what's the concept of continuous profiling? The idea is it's an observability method. It goes from profiling to investigation to optimization. Basically, the idea is to get an understanding of what's impacting your performance from the code point of view. So basically, get an understanding of the code level performance, identify bottlenecks, understand what's hogging CPU time, and then you can go back to your code, refactor it, and see those results you're so much looking for. And basically, you optimize those resource-consuming parts, you fix the performance issues, improve application performance, and reduce costs. So basically, going back to what I mentioned before, the way that we look into optimization. So when do you want to turn to profiling? The way we see it, there are two main reasons to turn to profiling. The first one would be root cause analysis. So basically, you have a problem in your environment, you want to fix it, you want to see results, you want to make sure you don't have any problems happening in production environments. So it's initiated due to a performance issue. So for example, that P99 latency could be spiking. You have one container that's going bananas, so you want to see what's happening, and you want to fix it as soon as possible. So you investigate a specific time frame, you look at the specific issue, you try to fix it, roll back, and rewrite the code in order to overcome that specific problem. On the other hand, the second use case is a more opportunistic approach, where you want to go without any specific problem you want to solve. It starts off from, the initiative starts from optimization, so basically trying to improve performance and reduce costs. You investigate continuously throughout all the life cycle of your application, and you opportunistically look for those optimization opportunities. But it's important to know that if you see that both use cases, at the end of the day, you find a problem, you fix it, you roll back, you rewrite code, and you optimize application cost and performance. So how does it work? So what's this concept of continuous profiling? The idea is to continuously sample the CPU. So basically, it's comprised of two main components. One will be the profiler. You would install it on your environment. So basically, install it on a production environment. It samples the CPU continuously. And the concept of continuous profiling is enabled due to the fact that we use not a lot of, it's very CPU consuming. So basically, we sample it at a frequency rate that's not high, that's taking up a lot of CPU. And on the other hand, it needs to be at a place where we can continuously do it and get a good understanding of what's happening within your environment. Basically, what we do is we record the kernel stacks and the user mode stacks and build a cumulative graph that shows you the entire application flow from the code point of view. We visualize those results, and then you can see a system-wide view of exactly what's happening down to the last line of code. Once that happens, you can start investigating that graph. I'll show you just in the next slide how it looks. You can identify code hot path, bottlenecks, and then you can go back to your code, refactor it, as I mentioned before, and optimize performance and cost. So what are the benefits? This goes back to what we started off with. So basically, we all want to optimize for cost. We want to have our applications running at optimal performance, and this, of course, also impacts the stability of your application. So basically, that's the reason turning to profiling. It's a self-serve motion in order to improve those key performance indicators. And that's what you guys are seeing in front of you is called a flame graph. So basically, the concept of a flame graph is the most common way of looking into profiling data. The way it's built, it's a graph, colorful graph, built up of many different runtimes. So in this case, we're looking at a Python application. So you guys can see it's starting from the frame. It's a little bit hard to read, as I can see here. But the first frame would be add to cart. So that would be a specific function that's executing in the given time frame in your production environment. And from there, it's calling a function called get that's calling request. So basically, it shows you the entire application sequence that's happening in production in real time. Basically, each one of these is called a frame. So a function call is called a frame. And the deeper you go in, it shows you the entire stack frame. So basically, one function calling a different function, calling a different function, the same way it happens in your production environment. So the y-axis would represent the stack frame, the call stack, sorry. And the x-axis would show you how much CPU time is spent on each one of the different functions. So basically, the wider it is, means it's taking more CPU time. And as you guys can imagine, basically, we're looking for those wide frames, which means a lot of CPU time is spent executing those functions. Each one of the graphs colors indicate a different runtime, so we can see, as I mentioned before, from kernel to the different runtimes that are executing within your environment, you would see them indicated in different colors. Now, I'd like to introduce to you guys a product that we've recently released. It's called a GProfiler. It's an open source and free profiler that we released as part of a community play. So basically, it's a tool that we developed in-house in order to solve our own internal problems. It started off from searching for other profiling tools in the market, and we couldn't find one that was exactly matched for what we needed. So we decided to build one on our own, and as part of a play for the community and try to get the word out for profiling, we decided to open source it and give it for free. Basically, what makes it unique is the fact that it's production profiling, and the key concept behind it is that we wanted to make production profiling as easy as possible for any developer team to be able to pick up the profiler and start profiling today. Basically, what allows us to do that is that low overhead. It doesn't take a lot of CPU to get it up and running. You can run it all the time throughout your entire environment. As I mentioned, it's free and open source. It's comprised of two main parts. So one would be the profiler itself. You deploy it on your environment. It starts to sample the CPU, and then you're able to see that execution graph I mentioned before. The second part would be the UI itself. So basically, you can investigate the performance, find those hot paths, and understand what's currently hogging your CPU. In addition, we've built it as an optimization tool. So basically, it's an optimization-driven profiler. It ties us back to those use cases I mentioned before. So we focus more around the optimization and less around the root cause analysis. In addition to that, you guys can see all the runtimes that we support, so from Java, Go, all the way down to C. Basically, we have all of those runtimes covered, so you can see the entire picture of your application, regardless of what type of application you're running. So I'd like to walk you through a few use cases of usage of this sort of tool. So in this case, I want to go through one that's an internal use case that we had. So we installed GProfiler from day one. So we deployed a new service. We had 10 machines running, and we installed GProfiler from day one. So basically, the profiler was running all the time. And then we started investigating it and trying to understand why it's not behaving as we expected it to be behaving. Once looking into the graph, we identified that 40% of the CPU time over a given period of time was spent performing regexes. And I'm sure you guys know regex is not a very efficient method of performing string operations, and 40% is, a massive amount of time. And so we investigated, and we thought this would be a great place to optimize the code. So what we did is we replaced all the regexes within the application with what's called a finite state machine. So basically, it's an alternative to using regexes, and we were able to reduce CPU time from 40% on that specific function down to 9%. So that's a massive reduction in the CPU time spent on that specific operation. And the results were CPU utilization of the entire cluster went down from 50% to 25%. So that's a 15% reduction of CPU. And we were able to reduce the size of a cluster starting off from 10 down to 4. So that's a 60% cost reduction just from a very simple operation. And that's something that, like the hard part about it was just understanding where we needed to optimize it. And just to make it so you can visually see it, as you guys can see, it's a little bit smaller than I expected. But the function over there, so it's showing you how much CPU time is spent executing that function. So you see here we have the main pulse stack frame. That's the function that's wrapping all of the regex. And as you can see down there, the different function executions are all performing different regex operations. So it's 40% of the cluster time, which is quite massive. And just so you can see how it looked after, so basically that's the same execution of the same application over the same period of time. But this time, this is post-optimization. As you can see, we replaced it, and we were able to reduce it. So the same wrapper, which is the main pulse stack frame, using the finite state machine instead of the regex, went down to 9%. So that's quite a massive improvement. And that was actually a relatively short time to execution. So basically, once we identified the problem, it took us not more than half a day just to refactor the code and write that finite state machine. Now I want to go through another example, and this time it's a customer of ours. It's a cybersecurity customer using GProfiler. In this case, they turned to profiling. They wanted to reduce costs. So basically, they wanted to improve their unit economics. They were very cost conscious because cybersecurity is something that's very compute heavy. So every small change can mean a big change in cloud costs. And they turned to it to reduce costs. So basically, they are a Django application, so Python. And they identified, while investigating GProfiler, they identified that 18.5% of the CPU time was performing an operation called get pkval, which is a Django function, basically querying the DB and performing some operation. And it indicates on unnecessary query operations to the DB, basically in their end. So they looked at the code. They said there shouldn't be so many DB operations. 18.5% of the entire cluster CPU time is a massive amount of time. So they decided to look into it and try to optimize it. And what they did was a pretty simple operation also in this case. Basically, usually the hard part just is finding what you need to optimize and not the solution itself. So in this case, what they needed to do is basically just cache the return values instead of making many different operations to the DB, and compare the values and just spare those unnecessary DB operations. And that resulted in the same function, the same operations they did before, with 18.5% of the CPU time, shrink down to just 3%. And that allowed them to reduce the size of the cluster down by 15%. So that's also a very simple solution, allowing them to reduce 15% of the cluster time, which is a lot. And once again, you guys can see the flame graph before and after. Basically, what I did is here is I just searched for the specific function. So get pkval is all the purple ones you see down at the bottom. You can see that total time of the entire application was 18.5%, as I mentioned before. And post-optimization, it went down to 3.3%. So basically, eliminating a lot of that wasted CPU time. So that's it from the continuous profiling. If you guys want to try it out, you can go by our booth and I can tell you a little bit more about continuous profiling, or alternatively, you can just go to our website, try it out yourself. It's free and open source. I'd love to hear what you guys think about it. Now let's turn to the second part, into continuous optimization. So just a few words about Granulate. So basically, we're an optimization company. We help enterprises manage their compute workloads to achieve reduced cost and improve performance. And we do it by a unique approach, something we call real-time continuous optimization. Basically, it's an autonomous optimization solution. It works very low level at the OS and runtime level. And what makes it very unique is the fact that we do it with no R&D effort, so no lift and shift from your end. And the results you guys see here up on the right are just some of the results we have been getting from our customers. We reduce the cost anywhere from 30, 40, sometimes 50 and more %. We are able to improve the processing time, so the job completion time. We improve the throughput. We improve the latency. Of course, it varies from one customer to the next, depending on what type of application, depending on what type of use case you're running. But one number that doesn't change regardless what you're doing is that number down at the bottom. Basically, that's a principle that at Granulate, we make sure there are no code changes, no R&D efforts whatsoever on implementation or going forward. Now, the basic principle behind Granulate is the fact that operating systems were designed as general purpose solutions for a user behind a keyboard in mind. Now, a user will be performing many different operations and running many different processes in parallel. And that's why the operating system tries to achieve interactivity from the end user and fairness between the different processes that are running. Now, on the other hand, if you look at production workloads, usually they use the single purpose approach, where each service is in charge of doing one thing and doing it well. And that's why you have repetitive patterns within your application. And that's why the allocation of resource is not tailor-made for that specific application. And that gap is exactly what Granulate comes to solve. Now, in order to emphasize what I just mentioned before, I'd like to walk you through an example to understand exactly what I mean. So in this example, what you guys are looking at, it's a Netflix application. So we have millions of users making a lot of requests to Netflix. Once they go to netflix.com, they go to the login service of the home page, and that triggers multiple backend requests in order to fetch the information and process the data and parse that page for the waiting user. So in this case, we have the login service. We have each one of these requests triggers a backend request. So just let's take 3 for example. So we have one service will be in charge of authentication in this microservices environment. One will be fetching all the new information, so what's new. And the last one will be building custom recommendations for that specific user. So in this specific example, this user A made a request to the login service that trigger that multiple backend requests. Or the authentication service is authenticated that the user is who he claims to be. What's new has returned all the information he needs. But the custom recommendation, since we're talking about a heavy operation, has not returned anything yet. So let's look from the front-end service point of view. So currently, the login service is allocating resource towards parsing the response coming back from the authentication and the what's new service, unaware that he cannot proceed with the application and return the response to the waiting user until he gets that custom recommendation response from the last service. And that's exactly what Granulate comes to solve. So basically, we make sure that the allocation is tailor-made specific for that application, and we make sure that the allocation is done properly once understanding the specific data flows within that application. So a little bit about our technology. So basically, we are an agent-based solution. We optimize performance continuously by adapting the application workload patterns. So basically, we learn the specific resource usage patterns, and we reprioritize them in order to make them better for your application, to improve performance and reduce cost. And basically, it's comprised of 2 main modules. So we have a kernel module that connects to the OS resource management mechanism within the kernel, and it makes prioritization and scheduling decisions in order to improve those decisions that are made. So in an example before, we wouldn't allocate resource towards handling the responses coming back until we know we can proceed with the application and we have all those responses coming back. On the other hand, we have the runtime module which does similar stuff, but at the runtime level. So basically, because the runtime masks away some of the functionality of the allocation and of the resources, we need to do similar stuff, but also at the runtime level. So some of the benefits of using Granulate. So basically, we enable performance improvement and cost reduction. We do it continuously, as I mentioned before. The first thing is the principle of no R&D efforts, no code changes, no R&D resources at all allocated towards this type of initiative. It's a fast time to value. So basically, you install it through a CLI, Docker, or whatever type of installation method you currently use. We can start off with just a single container, just a single VM, and go up from there. And we work with any type of infrastructure. So basically, because our approach works so low level, we are pretty much agnostic to what type of environment and what type of architecture you're running. And last is the fact that we're past initiative agnostic. Basically, no matter what you've done in the past, whether you've used, let's say, profiling, for example, or you've shifted to spots, or done any type of initiative in the past, you'll be able to see the same results in your application. Now, let's walk through the process a little bit and connect the dots. So we started off talking about profiling. So basically, the profiler has two use cases. One would be profiling for finding opportunities and understanding how you can improve your performance. And the second is we use the data coming in from the profiler in order to identify which workloads we can work on and how much value you'll be able to see using Granulate. From there, we take this data, we process it, and we analyze it. And that's what we call the learning phase. And we are able to understand those resource usage patterns and the data flows within your application and make those and build a configuration in order to make those smarter decisions for your specific application. Once we deploy the agent in your environment, we start seeing that optimization come into place. So we see the reduction of all the performance metrics. So job completion time would improve, latency would reduce, throughput would increase. And that happens immediately once we deploy the agent and it starts tailoring those decisions. And lastly, once we see CPU utilization dropping, as we've seen before in the case study of the profiling, we are able to reduce the size of the cluster, so basically perform the same tasks with fewer machines. And that's how you achieve that cost reduction you want so badly. So that's just a few words about the process. So what's the takeaway here? You guys can just go ahead and start using the profiler. It's free and open source. Go ahead and give it a try. I'd love to hear what you guys think. And we can use that data and then come back to you and say, listen, we can save you 20, 30, 40% on a specific cluster. So just a few use cases. We focus only on Linux at the moment. So if you guys have any Microsoft-based instances, it's not our go-to. And we work at any type of architecture, so whether you're running multi-cloud, single cloud, hybrid, on-prem, it doesn't really matter because our approach works low level. You'd see the exact same value. We can work in any type of microservice architecture, whether you're using Docker, Kubernetes, or VMs, bare metal, it doesn't matter. You can get the same value. And we also work on big data use cases. That's it for today, and I'll leave some room for questions if you guys want to ask anything. Sorry? So currently we focus only on CPU. Basically, most of the applications are bound by CPU, so we've started off focusing on those specific use cases. But I can say that we've seen improvements also on the memory side of things, because it usually is sort of tied up to the same mechanisms. Perfect. Anyone else? Okay, so thank you so much for being here, guys. I enjoyed it a lot. I hope you guys enjoyed it as well. And feel free to stop by our booth, and then we can go through a demo or ask any further questions you guys may have. Thank you very much.